LLMs, large language models, are one of the most impressive pieces of tech we had in a long time. But from a developer's viewpoint, LLMs are the ultimate flaky thing to test. They're kind of a nightmare to test, aren't they? Let's see. First, language models are non-deterministic by nature, so you give the same input and you have 1,000 possible outputs. Second, they have a tendency to make up stuff, like in the case of Air Canada's chatbot, which completely invented a discount policy out of thin air. A judge made the airline liable and they had to pay damages in the end, by the way. Third, LMs are also easily tricked via prompt injection. It didn't take much to convince a chatbot from the Watsonville Chevrolet dealership to sell a 2024 Chevy Tahoe for $1. Also, there's a tool created by Kate Grayshake which hides a message in your resume. It puts a hidden message in your PDF and it makes AI models think you're the perfect candidate for the spot. Clearly, LLMs, like any other piece of software, needs testing. The problem is traditional testing strategies don't work well. A lot of testing around LLM-powered applications rely on manual work and doesn't scale really well. Today we're going to focus on how to automate unit testing for AI and LLM-powered applications. So to test LLMs, like any other application, we need to compile a list of use cases. So what are the use cases for my app? What kinds of prompts will the LLM receive? We must narrow down the test cases as much as possible and generate a good set of tests covering different ways in which the application can work and in which users can interact with your application. Like anything related with machine learning, we need data, good quality data, good examples of prompts that the LLM will receive. We also need to think in which ways the user can abuse the application. In some cases, it's not the end user, but some other tool, like if you're building an application that scans PDF, you may receive a prompt injection via the PDF, or if you're scanning the web, anything can enter the context window of your LLM. So we need to compile a list of possible attack vectors. I've been talking to developers and so far I've seen 4 types of unit test. The first is example-based testing. Then we have property-based testing, Autoevaluation testing, and adversarial testing. Let's go through each one by one. In property-based testing, we ask the LLM to generate or modify a text in a very specific way and check the output for properties that we expect. For example, let's say we are working with the OpenAI API. We're setting a system message where we ask the LLM to only provide the answer without any other explanation. And then we're asking in the user prompt to solve a quadratic equation. We know the answer to this equation, so we can compare the result from the LLM with the actual result from the equation. This is one example of property-based testing. We are testing the properties of the output. Another popular use of LLMs is for making summaries. So we are providing an input text that's quite long and asking the LLM to make it more concise. And here we can compare the outputs, compare the length of the input string and the output string, and if the output is smaller or shorter than the input, then the test passes. We can use property-based testing for text generation. For example, we can ask the LLM to write a cover letter and we put some boundaries, like it has to be shorter than 400 words and it should mention some kind of role, for example, DevOps engineer. And our test in this case is to check the length of the output and to check if the word DevOps engineer is inside the output string. LLMs are good to generate code. We can use ChatGPT or Copilot to generate or refactor code. And one way to test this is to ask the LLM to generate some specific code to solve some task, and then first we can check that the code is valid, and then we can run actually the code, preferably in a sandbox to avoid any security issues, and see if the results match our expectations. In example-based testing, we use real cases, things that the user might ask our application to do. This will obviously depend on the nature of our AI application. Let's imagine we are writing an email responding application on top of an LLM. How do we test this? We need a little bit of prompt engineering here because the tasks are usually open-ended. We need some kind of structure. We can use, for example, JSON and ask the LLM to provide the answer in JSON format. A good start is to have two types of keys. One is the text, which is the output of the LLM, and the other can be an intent or a task. In the task, we put some categories that indicate what the LLM is trying to achieve. So we write a system prompt and we put all the existing tasks that we expect from our LLM. In this case, for example, we are answering emails, so we can accept an invitation, we can reject an invitation, or we can categorize the request as harmful and not comply with the request. Ideally, we also want to put some examples in the system prompt with, for example, cases where we accept or cases where the user has asked something that's out of the scope of the application. The more examples we have here, usually the better are the results. And then we can write the test by sending an invitation in the user prompt and saying, I want to accept this invitation. Then we have to check several things. First, that the output is indeed JSON, then that it has the correct key, the correct task, and the task is one that we accept. So in order to use example-based testing, we need to have as many variations of the task as we can. We should have multiple examples for each kind of task, and these examples can be generated by developers, can be generated by the customer. We can even use LLMs to generate more examples for us. In the last example, we ignored the text field in the output. We did that because there are so many ways in which we can politely decline an invitation, or so many ways to write a cover letter, that making assertion is very difficult. So we need a different strategy, and this is where auto-evaluation testing comes. We use a second model to evaluate the answer from the first one. Let's imagine we are working on an application that writes cover letter. We supply a list of skills and we ask the application to write a cover letter with the skills in a professional tone. How do we evaluate that these properties are correct? We can take the output from the language model and feed it with the system prompt to evaluate, saying this is the cover letter, does the cover letter have these properties, and we can get a result like yes or no, or we can get some result in a scale like from 1 to 10. The downside is that this kind of tests are more expensive because we need to make more inference and they're slower. So to implement this test, we start with a letter that was generated by the language model with a prompt and a list of skills, and then we make a second request saying this is the criteria that we need to meet. So you need to answer either yes or no. Does it meet the criteria or no? And then we can make an assertion on the output. If the output is yes, then the test passes. The last type of testing we're covering today is adversarial testing, and this is an extension of example-based testing where we put prompts that try to trick the model into doing something we don't want it to. The idea here is to prevent as much as possible prompt injections like the one suffered by the car dealership. Bear in mind that the prompt defense is still an unsolved problem. There is no 100% certain way to prevent injections. As long as the attacker has access to the context window in the language model, there's always some way to trick the language model to do some injection. The best we can do is harden the system to make it less likely for attacks to succeed. The first thing is we need to gather a list of harmful prompts and harmful inputs. We need to get as much as possible, as many as possible. We can ask a language model to generate them. We can gather them from examples or from user attacks. Let's say we have all our attacks in an array. We can iterate over this array and send the prompt to the model. And what we expect here is that the structure of the response is the same, that is a JSON, it has the correct keys, and the task is marked as harmful request. If any of these conditions doesn't happen, then the attack succeeded and the test failed, and we need to refine our system prompt to prevent that kind of attack. So let's recap a little bit the tips for testing language model. First, we should set the temperature to 0 to make the output a little bit more deterministic. Learn and use the prompt syntax for the model. Each model has a different syntax for the human and assistant interaction, so we need to use that correctly. During testing, we should log all the inputs and outputs and go over them manually each time, even if all the tests succeed, because there can be some cases that we missed, and we can also get ideas for more tests. If you are using the auto-evaluator strategy, you should also write tests to ensure it's doing the job, and if allowed by your privacy policy, you may log samples of anonymized user interactions. You can opt in or out of those to find new test opportunities. That is all for today. Unit testing for your language model is a vital part of software development. Just keep in mind that if your application interacts with other services, like it uses RAG or a vector database or function calling, you also need to implement some integration tests. And as always, you always need some end-to-end tests in your suite. If you like this video, why not share it with other developers working on AI? Also consider leaving us a like or following us for more content. Thank you for watching and have a nice one.